Hello friends, my name is Vaishnav Borkute from Yashwantrao Chavan College of Engineering Nagpur, intern embedded system intern at Emertxe Information Technologies Private Limited, and today I am here to showcase you the project which is washing machine simulation using PICsimLab. So first of all we will see the table of content, introduction, internship overview, internship goal, Embedded C, which has this type of things: keypad, data types, conditional statements, arrays, operators, functions, pointers, macros, microcontroller selections. We will use PIC16F877A, which has this type of functions: pin of MCU, interrupts, timers. And the next part is software requirements: MPLAB XIDE, PICsimLab XC8 compiler, and the peripheral which we use is CLCD, fan, buzzer, switches. So we will begin with the internship overview. The internship at Emertxe Information Technologies focused on developing an embedded system-based washing machine simulation using PIC microcontroller within the PICsim virtual environment. It provides hands-on experience in microcontroller programming, embedded C, and simulation tools. Participants learn to work with real-time systems, control flow structures, and sensor actuators interfacing virtually, simulating a real-life appliances. The project involved creating a washing machine logic controller that handles water filling, washing, rinsing, spinning, and user input through buttons and LEDs, mimicking hardware behavior in a safe, testable simulation. Now let's move toward the internship goal. The main goal was to design and implement an embedded firmware that simulates the complete operation of the washing machine using PICsimLab. This includes understanding and applying embedded C programming concept using timers, GPIOs, and control logic to model washing machine cycles, simulating sensors and actuators interaction virtually, building a functional state machine to control different washing phases. Now let's move toward the introduction of washing machine. Washing machine basically have become an essential part of our daily life, revolutionizing the way we washed our clothes. What was once time consuming and physically demanding work has now become easier thanks to those modern marvels of technology. From the early days of manual labor to today's smart devices that can particularly wash clothes for us. Now let's move toward the next part. What is embedded system? An embedded system is a special purpose computer system that is designed to perform dedicated functions or tasks, often within a large system, unlike general purposes computers like laptops or smartphones. Embedded systems are typically optimized for specific applications with real-time performance, low power consumption, and compact design. Here we can see the embedded system which is inbuilt. Types of embedded systems. There are basically four types of embedded systems: standalone, real-time, network, mobile. What is standalone? It is works independently. Example, digital camera. What is real-time? Must respond instantly. For example, anti-clock braking system. What is network? Connected to a network. Example, smart thermostat. Mobile, portable and battery powered. Example, fitness trackers. Here also we can see the AI generated image of the microcontroller and embedded systems. Type of embedded systems. So here we can see the embedded systems are based on two types: based on performance and functional requirements, and other is based on the performance of the microcontroller. Based on the performance and functional requirement, they are divided into four parts: real time, standalone, network, mobile. Based on the performance of the microcontroller, it is divided into three types: small scale, medium scale, specific. Let's move to the embedded C. Embedded C is a variant of C programming language tolerated from embedded systems. It focuses on how low-level hardware access, optimizing resources uses, and ensuring real-time performance. Programmers interact closely with hardware peripherals and often work within specific compiler environments. Embedded C enables efficient and reliable code development for devices with limited resources, such as microcontroller and embedded processors. Keyword in C languages. These are the keyword in C languages. For example, auto, const, double, float, int, short, struct, unsigned, break, continue, else, for, long, signed, switch, void, case, default, enum, goto, register, size of, type def, volatile, char, do, extend, if, return, static, union, while. So these are the keywords in C language. Let's move toward the data type. There are three types of data types: primary, derived, user defined. What is primary? Void, int, char, double, float. What are derived? Array, references, pointers. What are user defined? Structure, union, enumeration. What are the operators in C? Operators are something that perform the specific operations in the C language or any other programming languages. So here are the list of operators and the types given by them. Here are the unary operators, arithmetic operators which is used to for plus, minus, subtraction, addition. Here is the operator, relation operator used to check the relation between the two numbers: greater than, less than, greater than equal to, less than or equal to, not equal to. Here are the logical operator and or not, bitwise operator, assignment operator which is used to assign a value to the variable, and ternary operator or conditional operators. Conditional statement is the here are divided into two. One is if else and switch. In if else there are four types of conditional statement: if else, if nested if. If means if the condition is true, then it will create the output true. If else, it will check the condition. If condition is true, then it will print the what is mentioned in the if, or else it will print false. If else, if else, if the condition is true, then it will print, or else it will move toward the else if part. If else is false, then it will move toward the else part. Nested if means there is a if condition in the if loop. What is switch? Switch is the expression where we can type the multiple cases to print the statement. For example, here is a case 1 break statement, case 2 break statement, case 3 break statement, and default. Defining input output pins. Here are the ports and here are the DDRs. Port A, port B, port C, port D, port E, and trace A, trace B, trace C, trace D, trace E. These are the inputs and output pins. Interprets. It is the signals which means the processors to stop its current task and proceed to execute a handler set for interpreting sources. Interrupt sources, they have so internal interrupts and external interrupts. Classifications. They have two types: maskable and non-maskable. Here we can see the pin diagram of PIC16F877A microcontroller, which we use in the project of washing machine simulation using PICsimLab. Here we can see the microcontroller. Here are the pins which are mentioned using the labels. Here are totals of 14 pins in PIC16F877A microcontroller. Microcontroller PIC16F877A. The PIC16F877A microcontroller is an excellent choice for the washing machine project in the PICsimLab. 8-bit CMOS flash-based RISC CPU, 8 KB of program memory, 368 bytes of RAM, 3 timers, digital input-output pin 33, 10-bit ADC, analog to digital converter, 200 nanosecond instruction execution. So these are the benefits of using the PIC16F877A microcontroller. In this we get this kind of things. Timers. PIC16F877 microcontroller has three timers which can be used as timers, counters, or PWM. Tick based on the instruction cycle. Resolution, length of the timer registers. Quantum, period of the tick. Scaling, it is a method where we can delay the process of going into ISR if required. So here is the very important part of this project, block diagram. This is the microcontroller PIC16F877A. Power on switch 5, pause or stop switch 6, navigation switch 4, door status switch 1, display washing status color liquid, crystal display, buzzer, motor. Just in short, buzzer is used to produce the sound after the completion of the task. Motor is used to rotate. Switch here are the switch which are given the particular task. For switch 5 power on task, switch 6 pause or stops task, switch 4 navigation task, and switch 1 door status whether the door is open or closed. And here there is a display of the wordings. CLCD. CLCD is a dot matrix liquid crystal display. It can be used to display the characters, alphabets, numbers, emojis. It is available in different modules like 16 into 2, 16 into 4, 20 into 4, etc. It has 16 columns and 2 rows. It operates on 4-bit mode or 8-bit mode with microcontroller or microprocessor. Here are the pin given. VSS ground, VDD plus 5 volt, VO is for control, contrast control, RS is register select, R or W read equal to 0 and write equal to 1, EN equal to enable, DO to D7 equal to digital data pins, A to K equal to anode or cathode. So these are the pins in CLCD displays. So here are the softwares displays on the screen which I used in this project. First is MPLab XIDE, a robust and user-friendly integrated development environment IDE for designing, writing, and debugging embedded software for PLC microcontroller. Next is MPLab X68 compiler, a powerful C compiler that translates high-level code into efficient machine language uh, for PIC16F877A microcontroller. PICsimLab is a real-time emulator of a development board with MPLab X debugger integrated. Here is the PICsimLab development board. Here is the CLCD display. Here is the 7-segment display. These are the switches. Here is the PIC16F877 microcontroller, cooler to cool, buzzer, heater, resistors, and capacitors. Here is the reset button to reset the task. So here is the the board, and first we have to select PICgenian option. Then we have to select PIC16F877A microcontroller. Then we have to load hex file from the desktop. Open. Then the hex file has been uh, so next here is the options given on the screen, displayed on the screen. Daily, heavy, delicate. Using RB3 we can change the options. We can change the option. As we can see, there are a lot of options. A single press of RB3 means change the option. We can see there are dry only, wash only. We can see there are lots of options on the screen. If we have to select one of the option, so we have to press a long press on RB3. Here we can see low, medium, high, max, auto. Single press for changing the option and long press for this. Now we can see on the screen switch 5 to start. So we can so let's go back to the coding. This is the coding part. So for this first, it is a program for powering on and washing machine to display on the screen. So here, and after that we can see the coding. There is a very big coding of the C language, and here these are the options. We have done coding to display, and this is the option auto, low, medium, high, which was displayed on the screen because of this coding. And this is the coding to, and now it is given switch 5 to start, and we can also pause this by switch 6. We can see as the program start, the cooler start rotating and the clothes had been washed. To stop, we can click switch 5. As the program is running, the cooler also is running. Then to close, we can use switch 6. Please close.